Hi YouTube people, I'm teacher REGY SAFADÁO and today we are talking about the spatial geometry. Are you ready? So, come with me!
Hi, my YouTube friends. Welcome to our class number 1 of 6. Let's see our opening. As we already know, our channel is the channel of Mathematics with Frontiers, and here we have classes of physics, mathematics, and English in two versions, one in English and the other one in Portuguese. Go there and visit our video classes in Portuguese. They are really terrific. Okay. Let's see. Our today's class is going to be about spatial geometry. Let's see the definition and some examples, okay? Okay, so if you ask me what is spatial geometry, I'm gonna tell you it is part of mathematics responsible for measurement calculations involving spatial solids in a three-dimensional space, prisms and round solids. Let's see. They are geometric solids defined in a three-dimensional space, also known as 3D. Let's see some figures, some solids. The first one, the second one. Then I'm going to tell you the names of them. Okay. See? Now, the three first ones are prisms, and the three next ones are round solids. Okay, let's see. All right, let's see their names. The first one is a parallelepiped, also said cuboid. Cube is the second one. Then we have the hexagonal prism. Then we have a cylinder, a cone, and the last one is a sphere. We are going to talk about these buddies. All right, let's see. One by one. So spatial geometry, parallelepiped, also said cuboid, according to the country you live in. Okay, here in Brazil we say parallelepiped. Okay, so let's see the definition and some formulas of the parallelepiped. Okay, what is a parallelepiped? It is a three-dimensional solid formed by 6 parallelograms. Okay, here we have the solid. Okay, then we have A, B, and C. Then we have a straight line inside it, which is D. Then we are going to see their names. Well, the parallelepiped has 12 edges, 6 faces, 8 vertices, and 4 diagonals. The edges here, you can see A, B, and C, they are the 3 principal edges, all right? And D is the diagonal of the parallelepiped, okay? Well, let's see the formulas. If you intend to find the diagonal, you have to do the square root of A squared plus B squared plus C squared, okay? And if you want to find the surface area, you have to do 2 times A times B plus A times C plus B times C. And then the volume of a parallelepiped is A times B times C. Okay, so these are the formulas for calculating any parallelepiped measurements. All right, and then next one is going to be the cube, definition and formulas as well. So if you ask me what a cube is, I'm going to tell you. It is a symmetrical three-dimensional solid contained by 6 equal squares. Let's see the body. All right. A, if it is a cube, the 6 equal squares are all around it. Okay, A, and A. Okay, and the straight line inside it is the diagonal. Okay, let's see. So a cube has 12 edges, 6 faces, 8 vertices, and 4 diagonals. So A is the edge. And if you want to find the diagonal of a cube, you have to do a times the square root of 3. And the surface area is 6 times a squared. And the volume of a cube is a cubed. Let's see the next figure. So it is the uniform hexagonal prism. Definition and formulas. If you ask me, I'm going to tell you, it is a three-dimensional solid with 2 bases that are hexagons and 6 lateral faces that are rectangles. Let's see the body. Okay, you see? Oh, yes. So this is the height and the edge. So a hexagonal prism has 12 base edges, 6 lateral edges, 6 lateral faces, 2 hexagonal bases, and 12 vertices. A is the base edge, and H is the lateral edge. If you want to find the lateral surface, you do 6 times A times H. The base surface is 6 times A squared times the square root of 3 divided by 4. By the way, the square root of 3 is about 1.73. The surface area is 2 times the base surface plus the lateral surface. And finally, the volume of a hexagonal prism is the surface, the base surface times the height. Okay. Then next one is cylinder. Definition and formulas. Let's see. What is a cylinder? It is a solid geometric figure with a straight parallel sides and a circular cross section. Just 1 second. My window. All right, excellent. And then we have the figure right here. You can see a central point upper and down here. Okay, then we have the universal symbol of diameter. Radius is R, and the height. All right. Then we have the diameter is this. All right. You know, this is the universal symbol for the diameter. Radius is R. And by the way, R, the radius, is half of the diameter. Okay. It means that the diameter is twice the radius. All right. So here you can see this is the radius, and the radius is half of the diameter. All right. And H is the height of the cylinder. Well, if you want to find the surface area, you have to do 2 times pi times R plus H. Okay. And the volume of the cylinder is pi times R squared times height. Okay. By the way, pi is about 3.14. The next figure is the right circular cone. Definition and formulas. Well, what is a cone? It is every geometric shape formed from the rotation movement of a triangle. You see here? Yeah. Central point on the base. This is the diameter. As I told you, this is the universal symbol of diameter. Radius, R. Yeah. L, and here we have the height. Let's see. So the diameter, you know, the symbol radius R, with R is half of the diameter. Height is H, and the slant height, that is L. All right. Let's see. So the slant height is L. That is the square root of H squared plus R squared. Next, the surface area is pi times R plus L. And the volume is pi times R squared times H divided by 3. Okay? And pi, as I told you, is about 3.14. And the next one is going to be the sphere, definition and formula. Some countries around the world, people say sphere, okay, but both of them are the same thing. Let's see. So what is a sphere? It is every geometric shape limited by a closed spherical surface and which has all its points at the same distance of a central point inside it. Okay, so the body is right here. Suppose this central point is right there in the middle of the sphere. Okay, this is the radius r, and next one is the diameter. All right, let's see. So diameter and radius, as I told you before. So the spherical surface area is 4 times pi times r squared, and the volume of a sphere is 4 times r cubed divided by 3. All right, so these are the main formulas that we apply in a spatial geometry. All right, so as I told you, pi is 3.14. It's about it. Okay, well, our special thanks today for you, the ones who watch our videos until the end. Of course, thank you very much for watching them. Subscribe to our channel, ring our bell, and share this video with all those people you love. All right, and give us your precious like. It is quite very important for the increasement of our channel. I am your teacher, Regi Safadão. Thank you very much, and have all of you an excellent week. See you. Bye bye.
That's all, folks.